Welcome back everyone to another video here on the Unknown Coder YouTube channel. Today we are doing LeetCode problem 209, minimum size subarray sum. So this one is another medium problem as we can see here, and this one is very similar to the 2 sum except it's going to be multiple values instead of just 2. So now the problem states, given an array of positive integers called nums and a positive integer called target, we want to return the minimum length of a subarray whose sum is greater than or equal to said target. So like I said, this is similar to the 2 sum except instead of just having 2 numbers, we're going to go ahead and be looking for multiple numbers that get added up to equal or be greater than that target. We also want this to be the smallest number of numbers basically, so we want the smallest subarray. And then if there's no such subarray, we want to go ahead and return 0 instead. So basically if we can't find a subarray, return 0. So let's go ahead and take a look at the examples real quick, and then we'll hop into our constraints. So for example, number 1, our nums array is going to be 2, 3, 1, 2, 4, 3, and the target is going to be 7. Now keep in mind that this has to be a subarray, so we cannot break this up. It's not just going to be looking for, some 2 numbers in here that are equal there, so we actually need the subarray. So here it's going to be 4 and 3. So this means we want to count the number of values inside that subarray, so the output actually be equal to 2. All right, let's take a look at the next example. The next example, our nums is equal to 1, 4, 4, and the target is equal to 4. So here, we already have the number 4 here. So that means we only need one element from this array. So that means the output is going to be equal to 1. So these are valid things that could happen, so keep an eye out for those. And the final one, we'll have a nums equal to 1, 1, 1, 1, 1, 1, 1, 1, with a target of 11. So we only have 7 indexes here. So obviously, 1 times 7 is not equal to 11. So the output is going to be 0 because there's no way we can get 11 from here. Cool, so let's go ahead and take a look at the constraints and then try to figure out how we can solve this problem. So our constraints are fairly straightforward. The first one is 1 is less than or equal to target is less than or equal to 10 to the 9. So this just basically says the target can be between 1 and a very, very large number. I'm not going to write that out. Next one, it says 1 is less than or equal to nums.length is less than or equal to 10,000. So this means that the length of the nums array is between 1 and 10,000. So again, it's not going to be that big of an array. You don't necessarily need to do double for loops or anything like that, but if you need to, you could probably get away with it on this. And finally, 1 is less than or equal to nums to I is less than or equal to 10 to the 4. So this means the values inside the num array are between 1 and 1000. So again, nothing too crazy here, just some arbitrary numbers that they're giving us, nothing we need to really worry about. The only thing that will come in handy is the target being less than or equal to 10 to the 9. So this is a pretty big number, so we will have to work around that. But I'll talk to you all about how to fix that whenever I actually do the walkthrough and everything. So the goal of this problem is to try to keep a running total across multiple indexes in the array and try to find the sum so that they're greater than or equal to some target number. However, we're also trying to get the number of indexes to achieve this and as low as possible. So we're trying to do like multiple things at once. We're trying to find that target, but we're also trying to keep the size down of the subarray as small as possible. This is yet another medium problem that turns out to be a bit more complicated than it first appears. To solve this, we're going to use a bit of a 2-pointer technique that allows us to add different windows or subsections of the array together until we find either the small solution or we return from the array because we cannot find enough indexes to actually satisfy the target. Let's go ahead and take a look at the pseudocode and the walkthrough before hopping over to LeetCode. So starting out with our pseudocode, we're going to go ahead and say for all elements in the array, we want to go ahead and add the current value to the running total. Then after we added that, if we have actually gone over the target, we want to say, wow, we haven't reached the end and total is greater than target. So while our total is greater than target, we're going to go ahead and calculate our window size. Then we're going to go ahead and attempt to make that window size smaller by subtracting the current value from the running total. And after we subtract from the window size and everything, and it's still greater than target, we'll just continue doing that over and over again until we basically reach the end of the array. And then if we never found the target, we want to go ahead and return 0. Otherwise, we want to return the window size we found. So once again, this is a pretty complicated question. However, it can be done fairly simply, so that's pretty cool as well. So let's go ahead and get rid of this and let's hop into our example. Now this example is most definitely going to take up multiple pages, so I'm going to try my best here and try to figure out a way to edit this to make it work out okay. We're going to start with example equal to, and this is going to have a nums array equal to 2, 3, 1, 2, 4, 3, and target equal to 7. We're going to start with iteration I equal to 0. Our count is going to equal to 2 raised to the 32. Our sum will equal to 0, and our nums of I will equal to 2. So here, all we want to do is go ahead and add the nums of I to sum. And now our sum is less than target, so we just continue. So now I equal to 1. Our count is still equal to 2 raised to the 32. Our sum is now equal to 2. And our nums of I is equal to 3. So now we want to go ahead and add nums of I to sum. Sum is still less than target, so we continue again. for I equal to 2. Our count is still equal to 2 raised to the 32. Our sum is now equal to 5. And our nums of I is equal to 1. Once again, we'll go ahead and add nums of I to sum. Sum is still less than target. We just continue again. For I equal to 3. Our count is still equal to 2 raised to the 32. Our sum is now equal to 6. And our nums of I is equal to 2. Now, once again, we add nums of I to sum. And now sum is equal to 8, which is greater than target. And so now we go ahead and start our inner loop. So now for j equal to 0, our window is going to be equal to I minus j plus 1, which is going to be equal to 3 plus 1, which is less than count. So we're going to go ahead and set count equal to 4, because currently we have 4 numbers inside of our window. Then we want to go ahead and subtract nums of j from sum to make it slightly smaller and make the window smaller. And now sum will equal to 6, which is less than target. So we exit the inner loop and go ahead and continue with the outer loop. Now for I equal to 4, our count is now equal to 4. Our sum is equal to 6 again. And now our nums of I is equal to 4. Now we're going to add nums of I to sum. Now sum is equal to 10, which is greater than target. So we go ahead and start our inner loop again. So now we're at j equal to 1. Our window is equal to I minus j plus 1, which is equal to 4 minus 1 plus 1, which is just equal to 4. We're not going to do anything because count's already equal to 4. Now we go ahead and subtract the nums of j plus plus from sum, which ends up equaling sum equal to 7. So 7 is still greater than or equal to target. So we're going to go ahead and continue inner loop. Now j equal to 2. Our window is going to be equal to I minus j plus 1. So this is going to be equal to 4 minus 2 plus 1, which is equal to 3. So now we're going to go ahead and set count equal to 3. Our window is slightly smaller now. And we'll also go ahead and say sum minus nums j plus plus. And now sum is going to equal to 6, which is less than target. So we go ahead and exit inner loop and continue with the outer loop. Now for I equal to 5, our count is now equal to 3. Our sum is equal to 6 again. And our nums of I is equal to 3. So once again, we'll add nums of I to sum, which will equal to 9, which is greater than or equal to target. So once again, we'll start our inner loop for j equal to 3. Our window is equal to I minus j plus 1, which is equal to 5 minus 3 plus 1, which equals to 3. So we'll do nothing. We'll go ahead and subtract nums of j from sum, which will be sum minus 2. So sum will now equal to 7, and we'll continue the inner loop. So now j equal to 4. Window is equal to I minus j plus 1, which is going to be equal to 5 minus 4 plus 1, which is equal to 2. This is less than count, so we'll go ahead and set count equal to 2. We'll go ahead and subtract nums of j plus plus from sum, which is sum minus 4. Now it's equal to 3. We exit the inner loop. For I equal to 6, we're out of indexes. So now we want to go ahead and return count. Like I said, this one is a little bit longer explanation. I could have chosen a smaller example, but I wanted to make sure you guys understood what was going on. So let's go ahead and hop over to LeetCode and actually code this out. So over here on LeetCode, we're going to start with an int count equal to integer.maxValue. We're basically just using this to make sure we have some value that's going to be bigger than the max value stored inside the array. Then we need an int sum equal to 0. Then we're going to have an int s equal to 0 and an int e equal to 0. Then we want to say while e is less than nums.length. This is the part where we loop through the entire array. We're going to say sum is plus equal to nums of e. So this is going to add to our running total. Then we want to say while s is less than nums.length and sum is greater than or equal to target. So once we get the sum greater than target, we're going to start this inner loop. So we'll say int temp is equal to e minus s plus 1. This is basically our sliding window, and we want to go ahead and set count equal to the minimum of count and temp. So this is what I was saying. We either go ahead and reset the count or do nothing. If they're the same, basically they're the same number. It's not going to change anything. So we want to go ahead and subtract from sum. So sum minus equals nums of s plus plus. Finally, outside this, we want to go ahead and increment our e so we get to the next index and we don't do an infinite loop. Finally, we want to go ahead and check to see if count is still equal to integer.maxValue. If it's still at max value, that means we never got into that while loop and we never actually set anything, so we didn't find anything. So we need to go ahead and return 0. Otherwise, we'll return that count that we found. So, fingers crossed I didn't typo anything. These are the type of things that I typo all the time. So let's go ahead and give it a spin. And I actually got it first try. That's pretty good. We get a 1 millisecond runtime, which is basically as good as you can get. It beats 100% of solutions. Our memory complexity could have been a little bit better. It's probably not great because it's integer.maxValue, but it is what it is. I was trying to get as fast speed as possible. As always, if you guys did find some value in this or you just enjoyed the videos, please leave a like, comment, subscribe. Everything helps out in the YouTube algorithm. As always, my name is Ethan Uncoder. Hope you all have a great day, and I'll see you all in the next video.